Good morning and Jai Hind to all. Today we talk about some different functions and their derivatives. That is inverse trigonometric function. What is inverse trigonometric function and what are the properties of that function will be discussed later. Today we write some derivatives of that inverse trigonometric function. All of them try to understand and by heart that formulas. That means first is d by dx of sine inverse x. Derivative of sine inverse x, answer is 1 by root of 1 minus x square. Now discuss how to get this derivative. That means y is equal to sine inverse x. That is sine y is equal to x. That is x is sine y. Here the function is the form explicit function of y, and therefore we differentiate this function with respect to y, and derivative sine y is cos y. Therefore dy by dx become 1 by cos y. You already know sine square y plus cos square y is Pythagorean relation is 1, and therefore cos square y is 1 minus sine square y. Therefore cos y is equal to square root of 1 minus sine square y. That is 1 by square root of 1 minus sine square y. You know what is sine y? Is x, and therefore d by dx of y means sine inverse x. Answer is 1 by root of 1 minus sine y is x. We get answer x square. Similarly, we find the derivative of cos inverse x, derivative of tan inverse x, etc. That means our first was d by dx of sine inverse x is 1 by root of 1 minus x square. Derivative of cos inverse x is minus 1 by root of 1 minus x square. Then third is d by dx of tan inverse x. Answer is 1 by 1 plus x square, and derivative of cot inverse x, derivative of cot inverse x, answer become minus 1 by 1 plus x square. The derivative of sec inverse x, d by dx of sec inverse x is 1 by x into square root of x square minus 1, and derivative of cosec inverse x, that is cosec inverse x, answer is minus 1 by x into root of x square minus 1. That's all. So are the basic derivatives of the inverse trigonometric function: sine inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse and cosec inverse x. In this case, the function contains c, contain negative answer. That is, first we by heart these formulas. That is sine inverse x 1 by root 1 minus square, cos inverse minus 1 by root 1 minus square, tan inverse x 1 by 1 plus square, cot inverse x minus 1 by 1 plus square, sec inverse 1 by x into root of x square minus 1. And cosec is minus 1 by x into root of x square minus 1. Try to practice these formulas, okay? Now discuss some problem based on this case, this type of case. Y is equal to sine inverse x. Prove that 1 minus x square into y2 minus x into y1 is equal to 0. First we differentiate, is not y. Y is equal to sine inverse x. First we differentiate with respect to x, that is y1. You know the derivative sine inverse x is 1 by square root of 1 minus x square. 1 by root of 1 minus x square. Now we find second derivative because our proved term containing y2. Before finding the derivative of this function, is a right side is a fraction. So first we cross multiply the denominator to the left side, that is y1 into square root of 1 minus x square is equal to 1. Now differentiating again with respect to x. On left side we apply product rule, that is y1 into derivative root is 1 by 2 root of 1 minus x square into using function of function minus 2x, because derivative 1 is 0 and derivative of minus x square, minus of x square derivative 2x, plus second is 1 minus x square into derivative y1 is y2 and right side becomes 0. Here 2 cancel. Here the LCM is root 1 minus x square into 1, that is you can say LCM root 1 minus x square. On cross multiplying 1 into this term, that is minus x into y1. On cross multiplying denominator, that is root 1 minus square into root 1 minus square, that is root 1 minus square the whole square. Root 1 minus the whole square means 1 minus x square into y2 is equal to 0. Cross multiplying this and this. Okay, here the LCM is root 1 minus square into 1, root 1 minus square. Again cross multiply the denominator, and therefore we get answer 1 minus x square into y2 minus x into y1 is equal to 0. That's all we proved. Okay, first we differentiate with respect to x, we get answer 1 by root 1 minus x square. Before finding the second derivative, first we cross multiply the denominator to the left side, then we apply product rule and therefore we get answer. Okay, now discuss one more question based this case. Y is equal to tan inverse x the whole square. Y is equal to tan inverse x the whole square. Prove that 1 plus x square the whole square, 1 plus x square the whole square into y2 minus plus 1 plus 2x into 1 plus x square, 2x into 1 plus x square into y1 minus 2 is equal to 0. Okay, y is equal to tan inverse x the whole square. Here what is to be proved? 1 plus x square the whole square into y2 plus 2x into 1 plus x square into y1 minus 2 is equal to 0. It's a 4 mark type questions. These are very important questions. Okay, now we start to differentiating with respect to x, and therefore we get answer y1 is equal to, this is of the form x square. Now the chain rule, you know, x square, the derivative square is 2x, and therefore derivative of tan inverse the whole square is 2 tan inverse x into, then using function of function we find the derivative of tan inverse x. You know the derivative tan inverse x is 1 divided by 1 plus x square. That is 2 tan inverse x divided by 1 plus x squared. Now we find second derivative, that is y2. Before finding y2, we cross multiply the denominator of the right side. That is cross multiplying, we get answer y1 into 1 plus x square is equal to 2 tan inverse x. Again we differentiating with respect to x. On left side we apply product rule, because y1 is a function with variable x and 1 plus x is another function. Therefore y1 into derivative 1 is 0 and derivative x square is 2x, plus second function is 1 plus x square into derivative y1 is denoted as y2 is equal to 2 into derivative tan inverse x is 1 divided by 1 plus x square. Okay, again on the right side is a fraction form, so we cross multiply the denominator and therefore we get answer 1 plus x square into 1 plus x square into y2 plus 2x into y1 equal to 2. Multiplying this term we get answer 1 plus x square into 1 plus x square, 1 plus x square the whole square into y2 plus 2x into 1 plus x square into y1 minus 2 equal to 0. That's all, you get answer. Okay, we take first derivative and cross multiply the right side denominator, then we differentiate with respect to x, therefore left side we apply product rule and simplify, we get answer 1 plus x square the whole square into y2 plus 2x into 1 plus x square into y1 minus 2 is equal to 0. Okay, I will discuss one more question based on this type of problems. Okay, y is equal to is also a very important question. Is an I think it's a miscellaneous question, miscellaneous problems in your NCERT test. E raised to a cos inverse x. Y equal to e raised to a cos inverse x. Prove that 1 minus x square into y2 minus xy1 minus a square y is equal to 0. E raised to a cos inverse x. To prove that 1 minus x square into y2 minus xy1 minus a square y is equal to 0. Okay, now start differentiation. y1, you know, derivative of e raised to x. What is the derivative e raised to x? Is e raised to x, and therefore e raised to a cos inverse x derivative become e raised to a cos inverse x into, then here x corresponding term is a cos inverse x. So using function of function we find the derivative of a cos inverse x, that is a is a constant into derivative cos inverse x is minus 1 divided by square root of 1 minus x square. Minus 1 divided by root of 1 minus s square. First we find the derivative e raised to x, that is e raised to a cos inverse x, into using function of function we find the derivative a cos inverse. Here a is a constant value and derivative cos inverse x is minus 1 by root of 1 minus x square. Okay, now we find the second derivative because our proved term contain y2. Before finding the derivative, first we cross multiply the denominator to the left side, and therefore y1 into root of 1 minus x square is equal to minus a e raised to a cos inverse x. Again we differentiating with respect to x, we get answer y1 into, you know, the derivative root is 1 by 2 root of 1 minus x square into function of function, derivative 1 minus square, derivative 1 becomes 0 and derivative of minus x square is minus 2x plus square root of 1 minus x square into derivative y1 is y2 is equal to minus a e raised to, what is the derivative e raised to a cos inverse x? E raised to a cos inverse, that is e raised to a cos inverse x into function of function, that is a constant, and derivative cos inverse x is minus 1 divided by root of 1 minus x square. Okay, here 2 to cancel. Now on left side we select, we find that LCM. Here the LCM become root of 1 minus square. LCM is root of 1 minus x square. On cross multiplying 1 into this term we get answer minus xy1 plus on cross multiply this term we get answer root 1 minus square into root 1 minus square 1 minus x square into y2 is equal to, here minus into minus plus a square, a into a square e raised to a cos inverse x divided by root of 1 minus x square. Here root 1 minus square cancel and is equal to a square into, you already know what is e raised to a cos inverse x is our function y, that is a square into y, and therefore we get answer 1 minus x square into y2 minus x into y1 minus a square y equal to 0. That's all. It's a very important question. It's also it's a tough question, so try to practice them 2 or more times for getting the idea. Okay, now discuss one more question similar to this type of question. Y is equal to e raised to a sine inverse x. Prove that 1 minus x square into y2 minus x into y1 minus a square y is equal to 0, which is also similar to that our previous question. First we differentiating with respect to x, therefore y1 is equal to, you already know the derivative e raised to x is e raised to x, that is e raised to a sine inverse x into derivative a sine inverse x, a is a constant and derivative sine inverse x is 1 by root of 1 minus x square. Cross multiply the denominator, we get y1 into root of 1 minus x square is equal to a into e raised to a sine inverse x. Again we differentiate with respect to x on both sides. Therefore, y1 into derivative root is 1 by 2 root of 1 minus x square. Again using function of function, 1 derivative is 0 and minus x square derivative is minus 2x plus square root of 1 minus x square into derivative y1 is y2 equal to a into derivative e raised to a sin inverse x is e raised to a sin inverse x into using function of function derivative a sin inverse x, a into derivative sin inverse x is 1 by root of 1 minus x square. Here 2 cancel, and on left side we find the LCM. The LCM become root of 1 minus x square. On cross multiplying we get answer minus xy1 plus this term is root of 1 minus whole square, that is 1 minus x square into y2 is equal to a square into e raised to a sin inverse x divided by root 1 minus x square. Here root 1 minus square cancel, and a square into, you already know, e raised to a sin inverse x is y. Therefore, finally we get answer 1 minus x square into y2 minus xy1 minus x square y is equal to 0. That's all. It is similar to the last type questions. Okay. Now I try to do one more. I will do some on homework question. Try to find the answer. Okay. If log y is equal to tan inverse x, log y is equal to tan inverse x, prove that 1 plus x square into y2, 1 plus x square into y2 plus 2x minus 1 into y1 is equal to 0. Okay, log y equal to tan inverse x, first we apply exponential on both sides, therefore e raised to log y equal to e raised to tan inverse x. That means our function can be converted in the form y is equal to e raised to tan inverse x. Then differentiating. Okay, e raised to log y, e raised to log x is x and e raised to log y is y. Okay, try to find the answer. Okay, that's all today's class. Okay, next class we discuss more problem, or I mean higher order thing type questions based on second derivative. That's all. Thank you.